Thank you for subscribing to Infoverse Tech, where we explore new technologies in the areas of artificial intelligence, machine learning, data analytics, and similar. Today's tutorial is on Pandas. It's a very powerful library for data manipulation. It's a Python library. So let's get started. As you can see, I have my Jupyter notebook open, and I strongly recommend that you use this. It's a great learning tool and makes it very easy to run code, provide tutorials, and to understand how a particular Python function works. So as you can see, in this tutorial I'm starting with importing some libraries. So initially, for the first part of the tutorial, we will be requiring a NumPy as MP. So we import NumPy as NP and Pandas as PD. So these two libraries are very important, and the next two libraries we will be importing as we move through the tutorial. So let's run a very simple command to know what is the installed version of Pandas. So let me run that by selecting the cell, and you can see it's 1.0.5. So this is a quick example to show you how you can check version of Pandas installed on your system. Next, we can run another command, which is pd.show version. This will display all the versions of installed Python libraries. You can see that everything that's been installed so far. You can compare this to validate if you got the most latest version or not. Moving on, we look at some data types. Some of them are self-explanatory. You can tell by the name. It's an object, you have an integer, boolean, floating point, category, and so on. Primarily, Pandas works with data frames and series. In this tutorial, we will be working with data frames. A data frame is similar to an Excel spreadsheet or an SQL table. So creating a data frame. Here I'm showing a very simple data frame that can be manually entered. Later we'll see how we can generate a data frame as well. So I'm calling it cities and just choosing 3 cities. You have a similar key value pair. So for city, I'm putting in Toronto, some population, similarly for the other cities as well. Let's take a look at this. In this, when I run this command, it will be creating this cities data as a data frame using the pd.data frame, and you notice the case. So you have uppercase D and uppercase F for the data frame, and we move that into a data frame. We call it df. So let's run that, and it seems we have an error message. So let's go back, and maybe I forgot to run this. Sorry about that. Once I run that and I run that executes successfully. Now let's take a look at some of the data here. So df.head, this by default will show the first 5 rows. We don't have much data, but let me run that. So that ran, and it says okay, city, population, which is our data. I could also change that to, let's say, not the default, and let's rerun that again, and you can see that just showed the 2. So the default is 5, and you can add any number and it'll display that number, and the head denotes the first few rows. I can also replace this with a tail, and that will provide, if I don't give it a number, it will provide the last 5 rows of this data. Now I don't have that much data here, so I would still do 2, and you notice the difference here. So it is now counting from the last row upwards. Let's take a quick peek at what are the data types of this very small data set. And when I run that, it tells me that city is an object, population is an integer. Okay, now we notice that when we ran this command that we have population showing up as integer value, and you can see I have for Toronto 150,000, 20,000 for Helsinki, 30,000 for, these are all integer. Now I can run this command to actually change that data type from integer to float, and it's a very simple command. So you have df, that's the data frame, and the column in question dot as type, and you follow it with the desired data type, which is float 64. If I run this, it will actually change that to float from integer. I don't find it necessary to run it here, but it's a good command to know. Sometimes you do get data and you need to do some data cleaning or managing that data so it fits your model. So you might use this command to change some integers into floats, some floats perhaps into integers. Those kind of changes between formats are doable with this as type command. Let me show you an example of creating a bigger data frame. So I'm using pd for pandas.dataframe command, and here I'm using NumPy and generating a random number. 5-5, 8 suggests there's 5 rows and 8 columns. So when I run this, it creates a data frame of 5 rows, 8 columns, and all of the data is between 0 and 1. I can certainly change that number to, let's say, like a multiplier, and rerun that, and you notice that the numbers have changed. So now it's between 0 and 100, and they're all randomly generated. So if your use case requires a data frame with a large data frame with many numbers randomly generated, this is a very simple command to generate that. Let's move on to an actual data set. I have something called world cities. Now these data sets are available. One of the sites that I use very often is kaggle.com. So you can go there, check the name, and just download it on your desktop, and then you can refer that. Here I'm using the pd.read_csv to read this CSV comma separated file name here, worldcities.csv. So let me run that, and I'm moving that into df2, my data frame. Okay, so that ran successfully, and let me just describe. So describe is another command to provide more information about the data that's been moved here. So this gives us a count of the columns here, mean, standard deviation, minimum, maximum, and the percentiles. So a quick command to take a look at your data. We already looked at .head command, which by default shows the 5 rows. We also looked at tail, which shows the last 5 rows. As mentioned, we can add a number there to change the default. This one, the third one here in the list, is an interesting one, which is it can look at the data, but it will just look at the first 4 rows. So we're using a special syntax. So because we're not, for the rows, we're not beginning with anything, so but we're ending it at 4. So when we run this command, it'll show the first 4 rows of this data as shown here. Similarly, following from this same syntax, we have this syntax where I have 2 colons indicating I'm not selecting anything for the first starting point, but I have a dash minus, and dash minus indicates that I need to start from the last row. Let me take this out for a minute and let's run that, and you'll see that it as it indicates here, the comment, start looking at the data from the last row onwards. So when I run this, it actually, you can see that now it's flipped and it's looking at the last rows and moving upwards. I can add a dot head here and just to make it more readable, and it'll show us the last 5 rows from the bottom. So the last city in this database is ID 15488, and it's showing us all the data moving backwards. So very interesting format. I would ask you to look into this a little more. For this tutorial, I'll just touch briefly on this, but I would like you to explore this. Strongly advise to learn this syntax. Now we can move ahead and query the data. So as you can see, one of the column names is under city, so I can query the data by saying, okay, df2 is the data frame. I want to look at all the cities. Let me run that, and you see it shows us all the cities that are in this database. Let me see. So I can also, if I know the index number, I can use that using the iloc, which locates by numerical index. I can also do by LOC, which can take text base. So here I'm looking for a country which equals Canada. Let me run that, and let's see. Okay, so because we're covering so many cities, but the essential thing is that it's searched for where the column name matches Canada. So I can change that to perhaps Africa or United States of America, and it'll show me that detail. So we are essentially searching through the data, through the data set. Let me do another slightly complicated. So what I'm saying here is city is Athens and population is less than 50,000. So let's run this command. So city should be matching Athens. Now we know there are a few Athens in the world, so let's see what that brings up. So we have a city named Athens, and you have they're all in United States, and the population is under 50,000. So let me increase that to, let's say 500 or 5 million, and let's see what the result is this time. And you can see that we got Tennessee, we got Georgia added as well, and of course Greece. So very simple command to search for a column name. Here we were looking at city, and you have a condition to say, okay, where population is less than 5 million as an example, and you can quickly search through that database. The other commands are simply showing the max and minimum in this data set. I'll quickly skip over those. Very simple to do. I would strongly encourage you to try them on your own. This is an interesting command, the last one, where I can look at the -1 tells me that I can start looking from the last row onwards, but here it will reset the index to show me 1 onwards rather than the actual index of this. Because of this data set, I think the last the row is 15,000 something, but when I run this command, it will reset the index for me and show me the last 5 rows with the proper indexing. So let's run that, and you can see that this was the last city in that data set, and you have the index as per your request. We can also search based on data types. So here what we're doing is we are including number, and what we're saying is in that data set only show the columns that have number type data sets or D types. So let's run that, and you can see that it picked up latitude, longitude, population, and ID. These were the 4 columns in that data set, as you can see here, which have a numeric or D type or data type. Let's run the other command, which says something similar, but says it should include object. So let's run that, and we expect the rest of the columns to show up. So when I run that command, all the columns that are not numeric show up here. So you have capital, admin name, ISO 3, country, city, and so on. An interesting example is a very powerful command called group by. So what we are saying here is that I want to group by a country name and count all the cities under that. So if the country is Canada, show me the total number of cities. If the country is United States of America, show me all the total count. So let's run that and see how it turns out. Because we're not specifying any country, it's going to or should print out all the countries. So here you go. So starting from Afghanistan, which has 41 cities, Albania 26, and moving on to Zimbabwe, the last country alphabetically in our data set, it's got 23 cities. So very interesting way, and it's all possible by using this group by command. Let's have another query where we're saying we're looking for data where population is less than 10,000. Let's run that. You can see a number of countries that have, or cities that have population less than 10,000. Again, the query command quickly query or search through your data set. Let's take another example of cumulative sum. We have a data set called or data frame called df3 with some numbers a, b, c, and d, and the numbers in those rows. So when we run this command, we get a cumulative sum, and we're doing it on axis 0, which is the row. So you can see you have 5 plus 3 8 plus 6 14 plus 3 17, similarly 11 plus 2 13 plus 17 30 plus 33. So these are the numbers that are running down this column. So you add on the x-axis, the axis 0. Let's look at another example where you have a similar data frame, but you have some missing values shown by none. So let me run this. So the data frame df3 is updated to include those none values. Now we can run the same cumulative sum command, but here if we don't want to use those values, we can ignore them, and the way to do that is to add a command called skip NA, setting that to true. So let's run this, and we're doing this on axis 1, which are the columns. So let's run that, and let's see. So it's replaced that none by NaN, not a number, wherever it found that, and you can see that it's done the addition as well. Let's do a number of uniques in this data. So let's run this, and we notice that we have 4 values in the A which are unique. So 5, 3, 6, 4, that's correct. You have in B, you have 3 unique values, that's correct, 11, 2 and 3. You have 4 in C and 3 in D as well. Let's make a quick change. So let's say we make these, so we have 3 5s and 1 3. Let's run that again, and let's say we run this as well. When we run the number of unique, you should see that the D value changes, because we should sorry, the C should change, because we now have 3 5s and 1 3. That means 2 number of unique. So again, very powerful command, number of unique, to quickly look at all the and total the unique data in your data set. Now we will be looking at another data set called movies data set. Again, it's being downloaded from Kaggle. It's an open source, open to the public data set. So I'm reading that. You have the standard pd.read_csv. That's the file name. Let me just run this. So the data is now moved into df4. Let's take a quick look at the length, because I believe it's a very large data set. You can see it's got 45,466 rows. That's the amount of movies in this data set. Let's take a look at what are some of the top 10 in that list, top 10 rows. Let's take a look, and you can see it just displayed the first 10 rows. So you have adult, belongs to collection, budget, genres, homepage, original language, original title, and so on. A lot of information. Let's run something similar to what we did in the query, which is that I'm looking for some movie names, and under the column original title, which is shown here, original title. So I'm saying search. I'm creating a filter in that data frame to say that it should contain 7, Inception, Jumanji. These are the 3 movies that I'm interested in. This is another very powerful command called isIn, which basically will it's a Boolean result showing that is this data present in this data set or not. So let's run that, and now that's run, what we need to do is use that filter in the data frame so it can display our, you can see it picked up 3 matching our request, which was Jumanji, Inception, and 7. So again, this is using isIn feature of Pandas. I want to run this, or let's quickly do that. So this command will actually, you notice the same -1, and we know very well that when we see -1, this is the indication that we need to, Pandas should look at the row, the last row onwards. So what we're doing here is we are reversing the columns. So as you can see, the first column is adult, belongs to, and so on, appears to be in alphabetical manner. Let me just run this command, and you will notice that the should have reversed. So yeah, now it's alphabetically reversed. So you have the first one is vote count, vote average, and it goes all the way back to the first column is now, the last column now becomes adult. So again, use of this -1 is important to learn, and I encourage you to practice using this -1 syntax. Another very interesting feature of Pandas. So I have let me just quickly bring what I have. I have some data in this data set, and again a very small data set just for the illustration purposes. I select this data, I do a copy, I minimize this. When I come here, now my data from another worksheet, spreadsheet, maybe in OpenOffice or LibreOffice or Excel, I have copied that data into the clipboard. Now using the pd.read underscore clipboard, I can actually read that data into this data frame called df5. So let's run that command. So whatever I had copied from my spreadsheet that I was working on, it should have moved into a df5, my newly named data frame. And let me see if that data and you can confirm that. So this is the data that was in my spreadsheet, maybe in Excel or LibreOffice or OpenOffice, one of those other spreadsheets. Just by copying that and bringing it using the pd.read underscore clipboard command, I can read all that data here and assign it to a data frame. So very easy to manipulate this data. Let's look at another data set called Big 5 stocks, and again this is taken from Kaggle. So I'm reading it into df6. Let me do that, and let's take a quick look at the data. Perhaps I just want to look at maybe the first 10 lines or 10 rows, sorry. Let's run that, and you can see it picked up the first 10 rows of this data set, as it says the Big 5. So you can see Apple, Amazon, Microsoft, Google, and one other stock here. Let's look at some options to format this data that we have. So here I have open, close, and volume columns that I'll be working on, and you can follow the syntax along. For open and close, I want the data to be in 3 decimal places, and volume to have a comma in the number. So you can see here, this is let's take a simpler number. So this is 3,717,817. Using this format will insert for more better readability. So let's run this. And see if that worked. Okay, yeah. So you can see that open and close now have 3 digits for the decimal, and the volume is nicely added with those commas, and it's much more readable than before. Let's run another formatting. So here what we're doing is for open minimum, we're going to assign a yellow color, and for a maximum value of open for that day or for that data set, we're going to assign a cyan color. So let's go ahead and do that. And as you can see, in open, the lowest number or lowest figure was $8.08, while the highest closing highest price number was $2,367.32. So very quickly I'm able to label this data with the formatting that I wanted, based on my minimum and maximum configuration here in this very simple command, very simple formatting. Let's make another formatting change. So here what we are looking at is the volume column. We want it to have a different color so it stands out. We already made the change to add these commas. It's more readable, but running this additional formatting will color this volume column. So let's run that, and you can see that it uses a different, it's in a way categorize that as well. So you have the 57 million, the 79 million, 95. They're as the number increases, you have a more deeper or richer color for that number. So you can see for 0, the very low numbers, it's nearly, you can hardly see the color, but as the figure increases, it becomes darker. So I believe in this small data set, the highest number is 95 million, and it just, you can see, is the darkest color. So again, very easy to customize and change the formatting of this data set. Just a point here, I'm using, if you noticed, I'm using a subset because I just want to be, for you to be able to see it in one screen. If you notice, I read the subset stocks, but the actual big 5 stocks which you will download from Kaggle, I believe it has about 41,000 rows. So that's a big database, data set. The last thing, so as I said earlier in the this is a very high level tutorial. We're just touching on and giving you an idea that how powerful Pandas is and how you can use it. So many different commands and libraries to manipulate data for analysis and preparing that data, cleansing that data. All those tasks can be very easily accomplished with Pandas. The last one we want to look at is profiling a data set. For this, we need to import pandas.profiling library, which I had mentioned earlier on that we need to import these. So pandas profiling and then associated library pandas.util.testing. So let's go back here, and what we're doing here is another data frame. I call it df7, following the way we are naming these. We're reading the big 5 stocks. This time I'm reading the whole data set, and what we're doing is we are profiling it. So Pandas profiling provides a very quick view of the data, and it's HTML, and you can actually navigate in that. So we'll have a quick look at how that works. So let me read that data, and then I want to just comment this out and run the pandas._profiling, and that's the full syntax. .profile report with the capital P, capital R, and the data frame in question that you want to profile. Let's run that. You can see you have an asterisk there indicating that it's running in the background. So because of the size of this data set, like I said, about 42,000 rows, it might take a few seconds to prepare and show us the HTML formatted report. Let's give it a few more seconds, and in the meanwhile, I just want to thank you very much for your support and subscribing to this channel. My objective is to bring all the latest technologies and especially in the areas of machine learning and artificial intelligence, to be able to share whatever I learn, and hopefully will give you the encouragement to pursue a profession in this very exciting area. Okay, Great. So it shows up. This is the report on that data set. It starts off with the observations that they saw. Like I said, it was like nearly 42,000. The memory, it's giving you a snapshot of that data set. So you can take a quick look. You have total 7 different variables, some warnings about the data. Then they provide more details about the all the columns. So you have close, you have name, you have volume. I can toggle some details, and it will provide me further details on this particular as well, a particular column as well. So let me just toggle that back. You also get a heat map of the correlation, and you have all these different type of models that are used to generate these heat maps and correlations. So very powerful. Unfortunately, we won't have time to go into each model, but I encourage you to experiment and explore this very, very powerful tool available with Pandas. It talks about the first 10 rows of the data set and the last 10 rows of the data set. So this was a quick overview of Pandas, a very, very powerful library for Python that allows you to cleanse, prepare your data, and then do data analysis of your data set. Thank you very much, and thank you for subscribing.